do the audience warm-up thing. Wait a minute. Okay. All right. So we're not really, we'll wait a few seconds for, maybe for more people to come up. But so let me ask you, how many of you guys are programmers on your teams? Okay. And how many of you guys, why are you guys here? What do you want us to talk about? What do you want us to talk about? You want to learn. Okay, we're there. Anyone else? Anyone else want to do anything else besides learning? Yes. Oh, good. Okay, we're going to do that. And that's great. We've actually had a lot of people doing that kind of stuff. So, cool. Glad to have you. Anything else? I'm going to make sure we cover everything you guys want to know about. Yeah? Okay. So we're going to do some of that. There's also some really good videos online that kind of show how to do the WPILib programming. So maybe we can point to those later. So I guess we could start. All right, we'll start. So I'm Brad Miller, and so I'm from I'm the one who's actually from WPI. And do robotics engineering over at WPI, and also kind of started this whole WPI Live thing with FIRST back in 2008 or 7 or something like that, whenever we first started meeting about the C-RIO and getting the software on there. So I should do a plug for WPI. I did that before. Like, you have to keep plugging this. So you guys, if you're mentors, tell your students, if your students listen up, this is like really good. If you like doing this kind of stuff, we have a robotics engineering major at WPI. And surprisingly, last year, the robotics engineering starting salaries beat out computer science for the first time. It was actually the highest of all the 52 or 54 majors on campus, and had some like crazy high starting salaries. So, like Woody always says, it's not about the robots. Well, it can be. And you could just keep doing this as a career, and people get like really, really great jobs, doing stuff like Uber and Amazon Robotics and, iRobot and Waymo, and, all these guys are doing, all these car companies are making like autonomous cars, which are all like robots. So really good opportunities. Okay, so with that, I should introduce Peter, that's Peter on the end. Yeah, so Peter John, so we started out, when we first started out, it was like just me, and then it's a long time ago. But since then, the team of people who've been working on WPILib has grown a lot. So there's some like kind of core people who do a lot of stuff, and Peter is like kind of the leader of that pack. I mean, he did a new network tables implementation, he did the camera server stuff that you guys use if you're using computer vision. So, if you have questions about any of those things, he's the source and can tell you exactly how all that stuff works. So that's pretty good. And Fred was a student at WPI and got a master's, and now he's over at Microsoft writing compilers and stuff. So that's pretty cool. And has done a lot of contribution to WPI Live, and is sometimes an FTA, but today's a scorekeeper. So that's sort of the crew that's here. So what we want to do is give a little overview of WPI Live and talk about what was new for 2018. So the stuff that showed up this year. All right. So talk about the stuff that showed up for this year, and then talk a little bit about what we're planning on doing for next year, because we do this big kick over the summer. I mean, that's when we really kind of get going, and then it goes into beta around the October 1st or so, and so we'll do that. We'll do a little demo of some of the 2019 stuff, which I think you'll find interesting, and we're going to talk about how you build the components. We'll talk a little bit about the desktop tools that are part of the whole offering, because we do not only the libraries, but all those desktop tools like the dashboards and Robot Builder and Outline Viewer and all that stuff. And we'll talk about the components that make up WPI Live, and also about how GitHub works and how we do that. Kind of how we build stuff for you guys, and then how to contribute. And contribute, that's kind of interesting, because everything, One of the things that we did is everything has gone open source. And so you guys could look at any of the stuff you want, and it's all there. And as changes are made that you see in there, you see the pull requests, you see issues and all that stuff. So we encourage you to become part of that, and you're free to try and help contribute stuff. So we really appreciate that when we get when people report bugs and the answer at the same time. That's like really good, when they have the fix. So we're going to talk more about that. The whole idea of this is to try and make it easier for teams to be successful. And from my point of view, I like to see this stuff. I try and kind of aim at the like the 90% of the teams, to kind of raise the floor and let people do things, let teams do things that they didn't think that they could do, and get them to be focusing more on making the robot play the game and less on the esoteric details of how, I squared C, SPI sensors work, and stuff like that. Like you just get the data and it just works for you. And so for that, all the stuff is there. Oh, wait a minute. Did I say? Wait 1 second. Yeah, so I try to, that's my point of view, and I think everybody kind of shares that too. We really like seeing teams, especially like rookie teams and teams that don't have a lot of resources, be able to be really successful and be happy with what they did with their robots, and so that's sort of like what we kind of aim for. So that's why there's all these tools like like Grip and the dashboards and all that stuff. And the other thing that we're doing is we're kind of tracking what's in the kit of parts, and we're supporting all of that. So as new sensors and things get added to the kit of parts, then we generally kind of develop drivers and stuff for them in classes so that you can use those in your programs. Yeah.
First clearly knows about you. First bring their stuff to you before they put it in the kit of parts.
Yeah. Oh no, we do conference calls with them every week. We talk to them constantly. Okay, it's really a partnership, and I think like Kevin O'Connor, who's the first software engineer for stuff, you may have run into him at events and stuff, is actually does a lot of stuff. He's kind of actively helps develop some of this stuff, and so this is really yeah. So that's pretty good. Another thing that we try and do, and this is something that's very important to us and very important to FIRST, is to try and have parity across all of the languages. And what that means is that we don't want you to choose a language because it's got more stuff. We want you to choose, you want you to be able to choose a language that's right for you. And to that extent, we try and, as we add features to one language, we try and have similar features or kind of equivalent features if it makes sense for the other languages. And that's something that FIRST is very interested in. And kind of help us do that. So we work a lot with National Instruments, and a lot of the components that you'll see are from them. And one thing about this that's interesting is that we have like students developing some of the software, but the thing is that unlike like student projects in college or in high school or something, I mean this has to work for 60,000 students. And it's a pretty interesting experience for them to develop software that runs in that environment. So here's sort of the stuff that's part of WPI Live. So the team of people that I'm that I'm part of are on the left here, and we do all the C++ and Java libraries that you see. All the C++ and Java network table stuff, the camera server stuff. And then we do all these tools like Smart Dashboard and Shuffleboard and Outline Viewer, Robot Builder, Grip, and the C++ and Java tool chain. So we make it so you can use Java and C++ on any platform, for your robot, and hopefully it works well for you. National Instruments does the RoboRio image. So you run the imaging tool at the start of the year to put up a new image on there. That's them. They do the network communication, so that's the part that talks between, between the field and the robot code. and they do all the LabVIEW stuff. So all the LabVIEW language stuff comes from National Instruments. So if you have questions about that, you know, they're next to us downstairs. Those are the right guys to ask. And then the LabVIEW dashboard, which I think is actually labeled as the default dashboard or something, is from them. And they also do the FPGA code. So, you know, I don't know if you know, but inside the RoboRio, there's a processor called it's a Zinc processor from Xilinx, and it's got two parts to it. One of them is that it's got this dual core ARM thing, but sitting right next to it is a field programmable gate array, which is the hardware that processes all the sensor stuff. You know, so that's all done in hardware, not done in software. It makes all this stuff like really easy and fast. And then first does the FMS, the driver station FMS interfaces, you know, the field network configuration, the radios, and all the game and robot stuff. So they do, I mean, the rules, robot, you know, game and robot rules. So that's them. And so that's sort of how all this stuff kind of gets divided up. So our suite of projects, kind of like I said, is we do the C++ and Java libraries. The C++, so the way that C++ and Java work is the libraries have changed in the last couple of years, 3 or 4 years or something, where it's built in two parts. So there's one part called the hardware abstraction layer, which is the HAL. That's the part that deals with talking to the FPGA, you know, to the actual underlying hardware in the RoboRio, and figuring out all the registers and all the weird things you have to do to make that work. And then above that, there's another layer of software, and that's the language stuff that's either C++ or Java. And so we do those things. There's 2 graphical dashboards, which you've probably used. Has anyone used Shuffleboard? Using it? Okay, well, we can talk more about that a little bit later. And so this is stuff. This is the other stuff. There's a whole bunch of tools. We do a lot of the screen step stuff we do. I kind of found screen steps, and then we got that, made them a partner. And we do grip. You guys use grip? Yeah? Okay, so we do that. And you'll see I think you're gonna see some simulation coming back around again. So we're working on simulation stuff. So what was new in 2018? Well, so we did Shuffleboard, which is this new kind of extensible dashboard based on JavaFX. So the hope is that the interfaces can be much nicer looking, much more graphical, because the JavaFX components are all based on like style sheets and stuff. So you can have themes and stuff. So we have a dark theme and a light theme for JavaFX. We're spending a lot of time this summer making that work better. We changed some stuff in WPI Live. I guess what was the so you can see what the changes were. One of the things that was kind of interesting was last year there was this iterative robot class, that you could build your robot on, and that tried to sync up with the driver station data. So every 20 milliseconds it would run those periodic methods as data came in from like the joysticks from the driver station. But we found that the time is a little jittery, and sometimes people wanted to do control loops and stuff based on that timing, and it wasn't always 20 milliseconds. And so we kind of now defaulted to this thing called the timed robot-based class, which is based on a timer. And that thing really, that's pretty much, unless you run long in your code, that locks up with the time that you ask for. And by default, that's also 20 milliseconds. We also, this is really good, Azul Systems gave us a JRE to use, so we could never get a license from Oracle to do that. So now we can just push the Java runtime environment onto the robots automatically when you download programs. And so, we kind of check for it and then slam it on there. The deployment is awesome. Peter spent a lot of time doing deployment. So I don't know if you guys noticed the difference, but I mean, this year, the first time it takes a long time because it's putting a bunch of shared libraries and stuff and the JRE onto the robot. But after that, it's like, 3 or 4 or 5 seconds or something like that to deploy, and you're up and running again. So that's really, really nice. So we're really happy with that. And there were some issues with network tables. You guys have probably seen this where you get, you see widgets on network tables that are from, previous runs, and stuff, like previous versions or other programs and stuff, and these things are still hanging around. And so we did a lot of stuff to try and fix that synchronization stuff so that because what happens is network tables, any of the network tables nodes, whether it's a client or the server or something, just keeps a cache of all the values it knows about. And when something else starts up, it used to feed all that stuff to the other guy, and you end up getting like the OR of everything, this previous stuff plus the new stuff. So now it's much smarter about how it does that, that handshaking and deciding which values to pass around. And so we think it's a lot better now, and kind of more reflects what you want. Yes.
The cache was like persistent between restarts?
No, it wasn't that. It was, the problem is that if you had anything running that had network tables in it, it cached the values. And so what would happen is that if you left the dashboard running and you rebooted the robot, okay, the robot would get all the values from the dashboard, even if the robot started up a new program, okay? Or if you had the outline viewer running, which has network tables, or if you had shuffleboard running, which has network tables, or anything that was running that had network tables in it, when say the robot shut down and came back up again, it would just be, as a start, it would just get all the stuff from all those clients. So everything stayed in sync across the board. But if you were making changes to your robot program and you deleted some values or something, or you made changes, you don't want to still see that stuff everywhere. And so it kind of keeps track of who posted the thing, who added it the first time, and does some decisions based on that to figure out whether or not it should be replicated. Okay. There's also this new outline viewer, which is kind of nice. I don't know if you guys ever use it, but outline. So network table stuff is kind of represented. It looks like a directory hierarchy, So it's got paths. So you'll see stuff like smart dashboard slash X, smart dashboard slash Y, that kind of stuff, and so you can view that whole tree of all the values that are in network tables by running this program called Outline Viewer, and that's pretty nice. So you can see that. Oh, I guess I shouldn't really be. I'm doing this also because there's more slides to talk about this. All right, and then there's this. I guess we don't do this anywhere else. There's a new network console for logging stuff in. It was in Eclipse. Yes.
Outline viewer is in Shuffleboard?
Well, there's something that looks like Outline Viewer in Shuffleboard, and then there's a standalone program that's just the outline and the values. And you can create keys, and you can set values and keys and all that kind of stuff.
Is that installed automatically?
Yeah, it's in the tools directory. So it's right alongside of the Smart Dashboard and Shuffleboard and Robot Builder and all that stuff.
And it's installed as a program, so if I hit Windows key, Outline viewer, it'll show up?
No. It shows. It is in the Eclipse WPI menu, though. It's in in Eclipse. There's the WPILib menu. It's one of the options in there, just like the other dashboards.
Yeah. So that's pretty good. So what happened was, that was 2018, right? And they were kind of looking at what people are up to and what they're doing, and what they like and don't like, and that kind of stuff. And we noticed, one of the things that we noticed was that there were alternative build systems. Like a lot of people, rather than use Eclipse, wanted to use like IntelliJ. And if we're doing Java, how many of you guys do Java? And C++? Yeah, okay. So a lot of people who are doing Java wanted to use IntelliJ. It's a really nice IDE for developing Java programs. So this person, J.C. Brunning in Australia, came up with this thing called Gradle Rio, which is a bunch of Gradle configuration stuff that makes it really easy to add components to your program. And it just has some Gradle targets. Gradle is a build system, and it has targets, and the targets kind of tell it what to do. And so a bunch of targets were added so you can easily build and deploy programs. So you can really use it with any of these tools. And so people then were using IntelliJ. So we've been seeing a lot of that kind of stuff. We have this current vendor library stuff, which we'll talk about later, which is the way that third-party vendors like Crossroad Electronics and Wpi, for the NavX board, and all those guys supply libraries so that they integrate with WPI Live. So we saw some stuff that we didn't really like about that, and we'll talk more about it. We also see GitHub being used a lot by teams, and so we kind of saw that. And Java is increasing in popularity. I think Java, I don't remember what you remember the last year's usage data? It was like
more than 40.
What?
More than 40%.
Or, yeah, it's like about half or something, or half the team's using Java, and then the rest are split between C++ and LabVIEW. You know, I mean, Java's pretty nice, and I mean, we like it, or I like it, because it does error checking, you know, runtime error checking, and so you don't have like these memory issues, you know, where some memory gets overwritten and you don't know until 3 minutes later, you know, when you hit some corrupt data. Yeah. So IntelliJ has 2 licenses. One of them is the one you pay for. So if you're if you're in the business and you want all the features, you buy it. Then they also have a community edition, which is just free to anybody and has nothing. You know, it's not a first perk or anything like that. You just go to their website and you say community edition and you get it, and that's it. Oh, nah, it's never. We never asked, I guess, and it's never happened. But you know, maybe. But I mean, the features that the other one has are. Do you remember what they're?
It's all the stuff that is in the community or in the Pro Edition is things that enterprises need. So like Java EE support and all of these SQL database management stuff and.
Yeah, it's really
Yeah.
you're not likely to want to use this stuff in the things which you're going to do for robots. Yeah.
Oh yes, that's right. JetBrains/student. JetBrains.com/student. You can get free licenses as K through 12 or college students.
Yeah, so there you go. So for you don't even. It's not a first thing. It's just they're just trying to get students to pick it up so they'll. Well, yeah, but but you have friends who are students, so so that's okay. So, and the other thing that we're kind of seeing is people are wanting to do like more and more like kind of simulation, maybe for unit testing of their robot programs or testing stuff before the robot's built, because very often the robot is built like say on the first event, like when you're, like it gets finished then. Yeah, so all right, or it's never finished, you put parts in the bag or something, and so we're kind of, so that's another thing that we're seeing. So to address these things, here are our 2019 plans. Drum roll, please. And I'm going to hand this over to Peter, and he'll talk about that.
All right. So here, I'll put it in there so I'm not carrying it around. So 2019, what are we doing? We're going to Gradle Rio as a standard thing. And we're going to Visual Studio Code as the IDE, as the standard IDE. The reason why we're going to Visual Studio Code instead of something like IntelliJ, we need to support both C++ and Java. We don't forget about you C++ teams. We need to support both. And Visual Studio Code does. IntelliJ does not. IntelliJ just does the Java side. However, because we're basing this on Gradle Rio, we're really designing this to be 2 separate layers. So we really want the Gradle Rio side to work independently of whatever IDE you end up using. So, just like teams today are using IntelliJ with Gradle Rio, in the future they can use IntelliJ with our standard version of Gradle Rio. So we like things that we see and then we adopt them. So, it's growing anticipation of that. So that's the big news. Now, a couple other things is that we are going to start doing a Maven repo, and we're in discussions with the vendors in terms of whether WPI hosts it or they host it for third-party libraries. So trying to make that an easier process to install, just like Gradle Rio gives you an easy way to pull in other dependencies, we're going to use that same sort of thing to pull in third-party libraries as well to make that easier to install. The other new news is that the last few years we've been on Java 8, so we are going to Java 11. Which is going to be coming out this fall. We have, the plans here is that one nice thing is, while it was very nice that Azul Systems donated the JRE this past year and it allowed us to install stuff on the Rio without licensing considerations, Oracle actually contributed their just-in-time compiler to OpenJDK, open source, starting with JDK 9. So in fact, what OpenJDK 11 will have as the runtime is just like what the runtime we had last year. So we're kind of returning back to the Oracle just-in-time compiler and runtime for the Rover Rio. There was a couple of issues we saw this year with the Azul one, so hopefully those will go away. The other thing is we'll go to OpenJDK 11 for the desktop, and the reason to do this is probably a number of teams this year tried to install Java 9 and ran into issues because the tools didn't support Java 9, but Oracle was really pushing it. And it's also a separate download. So the big advantage of going to the OpenJDK JDK is that we can install it with our tools. We can package it and distribute it and install it and make it a really easy offline install, trying to ease the installation experience for teams. So the big part of that is we are building a single installer, at least for Windows. So the only separate download will be Visual Studio Code itself. We'll automate it so it's fairly easy to download, so it's still kind of easier than the old Java installer. You don't have to jump through 20 bazillion web pages to get that. And of course, we're going to also install the version of OpenJDK that's correct for teams to use and put that in a separate directory so it all ties together nicely. The other thing that's kind of the big news from the robot code development side. We're also taking some steps to make platform builds of WPI libraries easier for other platforms. This is mainly to number one, help you guys hopefully contribute stuff to us. That's making it easier to build as a part of that. The other thing is to make it easier to build for things like coprocessors, Raspberry Pis, that sort of thing. It's kind of a painful build process right now. We're combining some things and trying to make it easier to build, bringing in multiple build tool options. Our default is still going to be Gradle to build with, but we've done some work to make it possible to build with CMake as well for some of those processors coprocessors that don't have those tools. So that's kind of the big things. Certainly there's kind of a laundry list of other things. I'll go through this fairly quickly. One of the things is simulation usability improvements. Simulation, I know teams are getting more into that. We want to get more into it. We want to support that. It's been a little bit lengthy process. We weren't able to do it in a single year. We did some improvements to the hardware abstraction layers to make it easier to do, but it's a growing process, and that's definitely something we want to continue to improve on going forward. The other thing is the Pathfinder Library. A number of teams have used that this year. Definitely, of course, part of that is the game design. The game design really rewards doing path planning, but we think in general most game designs are going to, what is the number one thing you do in autonomous almost every year is drive. So trying to do some standardized ways of doing pathfinding and doing that in a path planning graphically, getting it into the robot side to get the robot to follow a path. Some software, things like motion profiling and software, command framework improvements. One of the personal projects I'd like to see happen is some support for state machines rather than just the simple where you just have the sequential or parallel commands. We added conditional command this last year, which is kind of a step on the way to getting to state machines. I'd like to kind of go the rest of the way. I'd also like to see some improved diagnostics out of that. I know a lot of teams just add print statements. That's certainly a good step to do that, but it'd be nice to have something a little bit more integrated there. Robot Builder, we've kind of evolved, particularly the C++ side of things, to be a little bit cleaner on as a standard way of doing it, but Robot Builder isn't respecting that yet, so switching that around. Shuffleboard, as Brad mentioned, lots of improvements there. Camera server, as I mentioned this morning, at this morning's, I want to see Windows Mac support for USB cameras, as well as, there's lots of other ideas in work, some of which I talked about this morning. And the other big thing, because of the changes we're making to the tools, we are planning on supporting in the future side-by-side multi-year installs. So you can keep the 2017 tools installed, keep the 2018, keep the 2019. You can have one computer with all of those installed simultaneously, and they won't interfere with each other, and you can open up a project and it'll use whichever year is appropriate for so the project keeps track of what year of development it's for. And similarly, like C++ tool chains will have a prefix in them to keep them independent as well. There was a question back there? Yeah. Sure. Yeah, we will post these charts probably on screen steps.
Yeah, we'll do, as soon as we get back, we'll put them up. So look at the home page for screen steps. I'll put a link there.
Yeah. One kind of it's a semi-minor change. It's actually a major change inside the libraries, and for C++ teams, it's something to be aware of. Is that we're moving. So we imported a bunch of LLVM, which is a big class of class libraries developed at University of Illinois, and we're moving those into the WPI namespace. We actually ran into some issues this past year with a couple of the dashboard applications on Linux where because we use the LLVM libraries, there was actually stuff on the system level that would also try to import a different version of it and ended up with name conflicts. So we're fixing that by moving it over to our own namespace. So that's kind of in a nutshell. We have clearly a lot going on for 2019. We're looking forward to a new IDE and something that's easier to use on that front. I will go through a quick demo here. We are semi-limited on time, so I'll try to make it fast, and Fred will go through his charts quickly. So just real quickly, so this is what the updated dependency tree is going to look like. So there's the Gradle Rio is going to use what you see on the left-hand side here is basically for the Robo Rio piece. There's this whole set of things. Currently, many of these pieces are actually in different repositories on GitHub. So NT Core, WPI Util, and CS Core are actually currently all in separate repositories. So that's part of the reason it makes it hard to build. You have to check out things separately, build it, and then build the thing that depends on it. So what we're going to do is we're going to merge that all back together into all WPILib. So this whole section of stuff that's kind of the background box behind each of these things. This one? Yes. Oh, sorry. My mouse isn't showing up. Yes, the left-hand one is so that big blue box is going to be all one repository and it'll all build with one Gradle build command. The right-hand one is basically the same thing but for simulation. So we're actually building the same set of code for desktop to enable simulation. Of course, all these tools depend on pieces of WPILib, and then what Visual Studio Code is kind of sets off to the side here because basically, again, what we're looking at doing with Visual Studio Code is it's a front end. It's a standard front end so that CSAs can support it, but really all it is it's calling into your actual project is running Gradle Rio, and that's what it's using for the build system. So if all you want to use is a text editor in the command line, that works too. Because but
You use Vim.
oh yeah, I use Vim and command line. So I'll do that. Yes, question.
So it looks like CTRE is not included in that?
So again, CTRE falls under the third-party libraries. So the plan there, and we're actually discussing with them right now about where it makes sense to hold a Maven repository. So Maven is what keeps track of dependencies, automatic dependency and version tracking for releases, and talking with them about, okay, are they going to host a Maven repo that we pull from? Working through those details. But the idea is that and we'll show a quick build script coming up here that that essentially you just add a line and it'll pull from their repository. All right, so let's talk about Visual Studio Code. So what is it? It is a free multi-platform. I would call it a modern IDE. It's kind of got it's tab-oriented, kind of I'll show some pictures of it coming up. So and it's kind of a little bit minimalist. It has some nice features like you can run it in full screen mode and stuff. So if you're screen space limited, you can do Zen Mode and throw away all the menu bars and stuff. So it is not the same as Visual Studio. I didn't want to emphasize that. They're two completely different platforms. It's actually written in JavaScript. It's actually a
TypeScript.
TypeScript, sorry, thanks. It's basically a JavaScript runtime, Fred. It's written in TypeScript. You don't need to worry about that. In terms of the team experience, really you'll be able to develop, deploy, and debug your code on the Robo Rio. So, and it supports both C++ and Java and other languages as well. So it'd be awesome if the Wpi folks would also be able to use it as the IDE because there is Python plugins for it. We do have templates for generating, or we aren't quite there yet. We will have templates for generating classes, things like subsystems and commands. The starter robot codes and sample programs that we've already implemented, I'll show that in a quick demo. And it does allow interactive debugging for both C++ and Java. So some early testing of this that we're doing shows that it's a little bit more robust than Eclipse. Eclipse was a little squirrely, particularly in terms of C++ debugging. So hopefully this will be a better experience for teams. And the other nice thing about Visual Studio Code and using the Microsoft distributed one of it is that there's many third-party plugins to enhance the development experience. So, you know, there's all sorts of, people have written thousands of plugins for this thing, or what they call extensions for this that allow you to do different types of development. So, so how's it set up? So at the moment, how we're looking at doing it is that there's a command palette. We're also trying to figure out if we can get some easier menu items and that sort of thing in there. We have a couple of those in. We're going to do some more work, but basically there's a command palette which you use. There's a hotkey to get into it, Control-Shift-P, and then you can just start typing WPILib, and there's a bunch of commands that are linked in there, and I'll show that in the demo. So this is what it looks like in terms of a visual experience. So this is with a robot program. One really nice thing about Visual Studio Code is it understands Gradle, so it knows what dependencies you have in there, and it will be able to do IntelliSense and show you pop-up about, oh, what is this class? What's the documentation? So just like Eclipse does, it does the same thing, and it shows the whole source tree and everything else, and it pulls that from this Gradle script, and it's smart enough to do that. So one question you might have is whether this thing runs on low-performance platforms, and the answer is yes, it does. So yes, that is a E09 2010 kit of parts 2-go PC, 11-inch laptop running an Atom processor, and I did run it in kind of the full screen mode to get rid of the menu bars and give me a little bit more screen space. But yes, it actually does run on that laptop. Not the speediest IntelliSense, not the speediest laptop, but it does work. It does actually run and compile, and you can get IntelliSense and see and really do development in it. It's probably actually faster than Eclipse is on this platform. I mean, this. No, that's 10 seconds. So yeah, for Java in particular, it's pretty fast. So. All right, so let's go to a quick demo here. And so what I'll do is I'll pull up Visual Studio Code, and it'll actually pull up the last robot project I had open, but I'll show creating a new one. So I just do Control-Shift-P, and if I start typing WPILib, I can create a new project for a template. I can create a new project from an example, so it has all the example programs in there. You know, debug, deploy. There's some options to set. It does keep track of the team number, and we've got it set up so that it will do. You can either have the team number be project associated, or you can have it globally for your user. So this is sometimes useful if you're, from a global for a user perspective, if you have like a practice robot or something that you set to a different team number, that's sometimes useful. It's basically set up to, and then there's going to be ways to start the tools, and we'll add a little bit more to it. In addition to the kind of menu options, we have started adding a little bit. We haven't added anything to the menu bar yet, but there are a couple of places where we can add things like deploy robot code here and do hotkeys. So like Shift F5 goes and builds the robot code. So what I'm going to do here is I'll create a new robot project, and so I can create a new project for a template. Okay, which language do I want to use? I'll do Java, and oh, do I want to do iterative timed command or sample robot? So I'll just do a quick timed, whoops, oh, I guess I'll do a command robot. And basically you just create a new folder, or if you're using Git, it does, one nice thing about Visual Studio Code is it does have built-in Git integration, so it'll actually tell you, hey, these are the changes in your files. But I can create, if you don't want to use Git, which I don't recommend, I recommend you actually do use a version control system. Git is what I would recommend. Yes. So you can just create a folder and go into a folder, and you can create it anywhere. There's no workspace in the same way that Eclipse has a workspace. I mean, I stuck mine into the downloads folder. You can do it in documents or wherever. And then you select folder and ask you, oh, would you like to open it? Yeah, let's go ahead and open a new project in a new window. And so this is what it starts with, and I'll close the welcome, but so what it builds out is it builds out your source tree. There's a build.gradle file, which I'll explain in a little bit, or Fred will explain. I think Fred will explain what it looks like. And then you just have your Java programs. And so here's the Java file. And one nice thing about this editor is that you can create split screens. So you can say, oh, let's just split it and see 2 views of it. It's kind of got the God mode view here, so you can kind of see, okay, where do I want to jump to in the program? You can have up to 3 of these in parallel. So you can, have, I want to see robot map at the same time. So I want to split that over here and close that window so you can see 2 things in parallel. There's all sorts of hotkeys to jump between windows. And as I mentioned earlier, it does have IntelliSense in it. So if I want to do a quick thing here where, let's add a camera. So I want to do camera server. Okay, there it is. It's in the WPILib project. I mean, it really is this fast. As you can see, interactively, it just kind of, particularly on a decent computer, and maybe not so much on the E09, but on a decent computer, it's very responsive compared to Eclipse. Yes, question? Is it like IntelliJ where it pops up automatically, or like Eclipse where it pushes it down? It's like IntelliJ where it pops up. I mean, it's popping up automatically as I type. So I'll do camera server dot get instance dot start automatic capture, and okay, I've done. So now I've got that in my code. So what it did is it actually went and imported it too. So it's in Java, it's smart enough to do that. I don't know about C++, whether I don't think it has the include files, but, and it does have mouse over help as well. So it shows, hey, here's the different options, and you can go and click on different things to get documentation for the different pieces of the libraries. And then, let's actually build this. So I've got this hooked up to a robot, and let's just do the build and deploy. So I just go to deploy robot code, and here it goes and compiles it, and it's and it's running on the robot. So did I start up the driver station? Oops. I guess to really convince you, I need to like print something, but But essentially, it's going ahead and running on the robot. So it really is a nicely set up system for doing the things you do in Eclipse. It's just definitely faster to start up, and a nice interactive kind of modern IDE. So as I said, one of the nice modern features about it is you can go to full screen mode. Or if you're really into things, there is a Zen Mode. So it's called, what is it called? I forget what the, Zen Mode. Control KZ goes to Zen Mode, where literally all you can see is just your code, if you really want to focus. And how do I get out of Zen Mode? Not that way. Oh, there we go. All right. So. Well, they really want you to focus on the code. All right, with that, so that was just a very quick demo of what it's going to look like. Again, we're actively working on this. We've gotten very far along already. Yes, question. No, they are not on Marketplace yet. So right now we've set it up as we do separate builds and it's VSIX files. So it's not in the Marketplace yet. That's something I think we need to talk about. We haven't talked much about whether or not we really want to do that, because I don't know what the release schedules are and that sort of thing. We are a little bit different environment. One of the things we're spending a lot of time on, and that like Gradle Rio the Gradle Rio today isn't so good at it, and we're spending a lot of time on. One of the key requirements for any new build system, any new setup like we have here, is that it be able to be installed off of a USB stick, completely offline, because many events do not have wireless. So and that's actually more difficult than it sounds, because a lot of things like Gradle and even VS Code like to download stuff off the internet. So we have to do some tricks with the offline installer to actually get it all installed on a PC off of just a USB stick. Yes, question back there. All of those control shifts, are those all the standard Gradle scripts, like you run those all in command line? Yes, yeah. So literally what it's doing is just it's just a standard grand, and actually you can open up a terminal here too, and I can run Gradle W build, and it will go and actually, well, maybe build.
You need to do dot slash.
Oh, dot slash.
Dot backslash. dot backslash.
What? It doesn't
You're
work
on
that way?
Windows.
It's Windows.
It's Windows, what? So yeah, and so all of those commands are again, you can use with a text editor and a command prompt. So like, and now this won't work, and we can kind of explain why. So the build.gradle file has in it a default team number. The VS Code provides a team number to the build script, but you can set it in the Gradle file as well. So I can't just do this. It'll say, oh, I can't find where's your RoboRio? I can't find it because it's trying to look for, as you can see from the shell here, it's looking for. It couldn't find the RoboRio. The reason for that is in this build.gradle file, the template one has team 5333. If I actually switch that to the correct team number, it'll work. So, but again, what we're trying to do with Visual Studio Code level is provide wrappers around all of this, so you can use it from the command line. If you aren't using VS Code, if you're using VS Code, it provides a nice GUI interface for doing all of that. Okay. So I'll switch back to the PowerPoint presentation here. Give Fred a quick chance to talk about. Or I can walk through what Gradle is, or Fred can do it. Fred's probably more qualified. So, all right, I hand it off to Fred.
So I'm gonna have to go real quick because
There's a timer on there.
we had like 50 slides and we're on 19. So you've seen Gradle now. Some of you clearly know what it is. Gradle is a build automation system. If any of you are using Eclipse now, you're familiar with Ant. That's what we're using currently, and that's what all our deploy tasks and compile things are written in for Java. For C++, we're also using somewhat Ant. We're using Ant to actually do the deploy, and we're using Eclipse's built-in builder to actually build C++ projects. For Gradle, it supports both C++ and Java, so we can use a single build system with a single set of tasks that we can share between multiple things. And make that work a lot better. It has a plugin-based architecture, so you can do, if you want to add this custom build step into your project, you can do that. It's really easy. Gradle files themselves are written in a language called Groovy. All valid Java is valid Groovy, and then Groovy is a scripting language that has a bunch of smaller, neat syntax for doing small, quick projects. It's good multi-project support, and it scales to large projects very well. We use it to build WPILib, and it scales to all of our projects. And it has integrations with lots of IDEs. If you still want to use Eclipse, there is actually a plugin for Gradle in Eclipse that you could use with it. And it allows us to build all of our repos with the same command. Everything just uses Gradle wbuild. If you want to run it, you run with Gradle wrun. If you want to deploy it, Gradle wdeploy. It all makes sense, so you can get lists of tasks very easily out of it. So Gradle Rio is an extension, as Brad mentioned, was written by an Australian woman named Jassie. And so she published it part of a foundation called Open Rio. And she has been working with us to make it a thing that we are going to use for everyone. So we're replacing Ant, and we're using Maven dependencies for adding dependencies to your project instead of having to deal with user folders and things like that. And everything is controlled by this build.gradle file. That's just the standard Maven convention. It looks for a build.gradle file and then uses that to build your project. So this is some parts of a Gradle Rio build. So at the top, you have things for plugins. So this is the Gradle Rio version itself. And then you can add things. So Java adds the Java support. If you want to have Eclipse support, you would add Eclipse. If you want to have IntelliJ support, you would add IDEA. Later on in the file, you would define your team name. You would define the startup class for your robot. Currently, this is in a manifest file that people don't know how to change. And there are a number of times on Chief Delphi or something, we'll see a post, it failed to launch this class. Well, that's because the class doesn't exist and you didn't know you had to go update it. And so I'm just going to breeze through this real quick.
Yeah, so we included this for reference purposes mostly. I mean, kind of walk through it, but essentially, as you saw in Visual Studio Code, when you're creating a new project from a template, it creates this file for you.
It'll have all of these things in it. And this is some examples of deploying to the robot and then using dependencies. And then some more examples of including other things in your jar. If you have some files you want to include from your build directory in your jar, it's pretty easy to do that. And then Gradle has this concept of a wrapper, which allows you to just clone the project, cd into it, and /gradlew build without having to install anything. And so we're currently working on ensuring that we can use GradleW and be offline, and that's part of the current problem that we're working on. But we should be able to get that done. I would love to be able to talk about building WPILib components, but we do not have time.
I don't know what you guys are planning to do. We got some dispensation.
We did?
We can keep going a little longer.
Okay, cool. Then I will talk about building WPILib components. Excellent. All right.
But not that much more.
Okay. I will talk about this, and then I'll skip the other slides to contributing.
We can just meet you down in the booth for that.
Yeah.
So previously, we had a bunch of different repositories. We're slimming that down, and we're only going to have a few different repositories, but this still applies. So network tables and camera server and all of this stuff are shared between repositories using Maven dependencies. So network tables is published as edu.wpi.first.wpilib.something.network tables. And we have two repositories set up on the web that anyone can just depend on. We have the official release builds at that URL, and then we have the bleeding edge every day. Whenever we make a change, this gets published there repository. Then we really don't suggest you use that. Like not unless you're actually trying to help us with builds. Local builds published to a local Maven repo so that they can be shared between projects. So if you had a change in network tables and you wanted to build all WPILib and test that change, currently when we make the change to an Uber repo, you won't have to do any of this. But say you had a network tables change you wanted to test in Smart Dashboard, that will still be in a different repo. So that would publish to this directory here. And then you will be able to use it in Smart Dashboard, and then we're going to be making some changes to Gradle Rio to, if you're testing a WPILib version, it will know to look here and use that version if it exists. Yes?
So you're saying this is if we were making changes to the WPI.
Yes, if you are specifically making a change and you want to test it out, Gradle Rio, we're going to make it so Gradle Rio will see that and depend on it automatically. Dependencies, all of our dependencies are suffixed with target platform. So network tables ARM, or network tables Athena for the RoboRio, or network tables Windows, or network tables whatever the Linux are. There are a bunch of different suffixes, and they change. The x86 is not the same on every different platform because Mac calls it differently than Linux, and I don't remember them all off the top of my head. And then we version our libraries with Semver, and we're using a slightly modified version of Semver. Most of our stuff is going to be year of competition .required update .optional update. So this makes it very easy for you guys to look at a number and for our inspectors to look at a number and say, all right, they need to be at least 2019.3. It doesn't matter what the minor version number is. You could have .4 of that. No one cares. But let's say we have some critical bug that we need to fix and that you're not allowed to compete on the field with, it's easy to check for that. And then we do have a couple of libraries that are published in standard style, in standard Semver, which is just major, minor, and revision. And you can read about that style at semver.org. Right. And we're going to skip the tools. No? No? Okay.
The one thing I want to talk about, we talk about the tools, so I don't want to go through all this stuff, because you guys don't. But one thing I always want to tell people is that we spend a lot of time trying to make the tools play together, okay? And the idea is that if it's like we have students, doing projects at WPI and they write a big report, there's a table of contents on it, and then the table of contents is like not correct. It's got the wrong page numbers. And you go like, how can you do that? how come it's wrong? And they say, oh, they didn't know that there were paragraph headings, and they didn't know there was all this stuff, and it would automatically construct the table of contents. So if you don't really know how the authors intended the stuff to be used, you're like always fighting the tools. With this, we have Robot Builder, which will generate a template of a program. But not only will it do that, but it will set it up so all of the subsystems that you use will show up on the smart dashboard when you're in test mode, so you can try everything in 2 PID loops and do all that other stuff. And all of the commands that you use will show up on the dashboard as buttons, so you can test the commands individually just by clicking buttons on the dashboard. So you don't have to write test harnesses or any of that kind of stuff. So the whole idea is that if you try and use the stuff that way, your life will get like infinitely easier than if you try to kind of go off on a different path. So try and take a look at that stuff and try and take advantage of all the places where you spend a lot of time doing integration to try and make this stuff really easy to use. So that was my sort of soapbox pitch, and I think we can probably skip all the rest of these things unless you have questions.
We do Smart Dashboard, we do Shuffleboard, we do Outline Viewer, we do Robot Builder. This is the stuff that Brad was talking about for Robot Builder automated test code. So when you generate things with Robot Builder, in Driver Station, there's this little thing that says test mode. If you click that and you say enable, you get this on the dashboard.
The other one.
Or, well, you get that one on the dashboard. And so that's all your subsystems. So you have a PID, and you can tune your PID from the dashboard without having to write anything special, without having to redeploy your code with, oh, I think we need to increase this one by 0.1 or whatever. You can just change it on the dashboard, and it just works. And you can see sensor output, and then in regular mode, you can see all the different commands, and they just are there, and you can run them and test them very easily.
Yeah, when your robot comes in after a match, and the drivers are saying, oh, the elevator didn't go up to the right height, you just flip the thing into test mode. There's all that code that's already it's already built in. It's all this harness. You just look at the potentiometer value on the elevator, and you can see if it's correct. And you'll know whether the hardware is broken or the driver is broken or whatever. And figure it out really fast. So
Because it's always a software problem, right, guys?
because it's always there, and that stuff. So again, test mode, your friend. It's good.
You got a question?
So I'm going to have to run to another session, so allow me to just ask a big picture question.
Okay.
On both of your plates.
Sure.
The fundamental question is when. I'm going to spin it with, how do our programmers learn how to work with all of this stuff in the fall, so that on January 6th they can actually start working with it and not learning something new?
There's a whole bunch of videos on lots of robot stuff, like how to use motors and how to use pneumatics and that stuff, and about how to use the software stack, so it works this way.
This stack, VS Code and Gradle.
VS Code and Gradle aren't there yet because we're not really developing. We'll try and put out videos for the fall as the stuff finishes, and so you can get a head start looking at it. For the rest of the stuff, like using Robot Builder, using command-based framework, using the dashboards and all that kind of stuff, there are videos up there now.
Well, and of course, in terms of we won't be able to really see extensions until and have them really, working until the kickoff. But you can certainly download VS Code and develop Java install the Java extensions and start, learning the IDE side of it is, and learning how things work at that level is very applicable.
So you shut something, I can't use VS Code and whatever
Right.
to push something
To the robot.
Robot.
That's right.
Well, so kind of. The thing to remember is that this is based. You won't have the specific extensions for doing this, deploying from one button press inside of VS Code. But you can today go install VS Code and use it to develop a Java application that you build with Gradle Rio, and then Gradle W deploy. And that all works today. You can do that with your stuff.
Yeah, and this is an open source project. So you can follow what we're doing, but you can grab stuff, grab releases over the summer and play with it. So
The VS Code extension is not public yet, but it will soon be.
Sorry.
well, thanks for coming.
All right. Speaking of open source, the last thing I would really like to talk about is how we do open source. So we're on GitHub. GitHub.com/WPILib Suite is all of our repos. The main repo lives at /all WPILib. And this is a pretty standard GitHub workflow. You fork if you want to make a change, you fork the repo, you create a branch, you commit your changes, and you submit a pull request. When you submit a pull request, we use Jenkins, Travis CI, and AppVeyor to test the code that comes in. Jenkins will run tests on actual hardware, so that needs us to actually say okay before we just start running anybody's code that they submit to the hardware in Brad's office. Travis CI and AppVeyor, however, are on someone else's computer, so we don't care, and we just have them run automatically. And so we run both unit tests and integration tests. The integration tests are the things that run in Brad's office, and those are on an actual test stand that we have with a RoboRio, a whole bunch of motors, talons, and all sorts of other motor controllers, sensors, and we have some test setups that allow us to say, all right, we drove this motor for this period of time. We know that given this setup, it should go to X, and did it or did not, and other things like that. And we have DIOs hooked up to other DIOs, so you can output on one and expect to read stuff on another to simulate limit switches and all sorts of things like that. After something has been merged, Jenkins will then check out and build on every commit, and then it will rebuild any downstream dependencies. So if you make a change in network tables, then all WPILib will get rebuilt, and the Eclipse plugins will get rebuilt, and that will change as necessary for the new stuff. And then, so development, that development repo gets updated immediately. It gets immediately the new stuff. The only thing that will cause you to not see it immediately would be Gradle or Maven caching, if it didn't check for some reason. For release, we have 4 different tags. Well, we have 3 different tags and no tag. So we have alpha releases, we have beta releases, we have RC releases, although we don't tend to use that label much. And we actually have full releases which have no suffix. So, for example, this year you would have 2018.1.1, and then previously during the betas we had 2018.1.1-beta 1, -beta 2, -beta 3, etc. So, for WPILib changes, there are some considerations that we have to make when taking software from teams. Everything in the library has to work for all the people who are going to use it. So your cool thing that works with your particular robot, while cool, isn't necessarily applicable to every team in FRC. We need to be able to support things, even if the author leaves and isn't interested in supporting it anymore. So we need to be able to understand it. It can't have these magic numbers that multiply things for no reason, that we can figure anyway. Again, tool suite changes must be applicable to lots of teams. We don't like taking team-specific changes. Usually, if we add features to a language, as Brad talked about earlier, making sure that any team can use any language, depending on what's right for them, we want to make sure that new additions to one language happen in other languages. For our stuff, that's usually just making sure it happens in C++ and Java, but oftentimes it can be working with NI to getting stuff added to the LabVIEW libraries as well. Library changes should have tests. I hope this is good software engineering practice. We like to follow those. And code needs to be documented. If we're adding new features, often that means screen steps changes. Often that means figuring out some way to let teams know about the new features. So, things to contribute. Bug reports. Absolutely. It doesn't, if you have a bug report, feel free. GitHub.com/WPILib Suite/all-WPILib. Don't necessarily need to have a fix. We'd much prefer to know about the bug and figure out how to fix it ourselves than to not know about the bug. If you can fix it, absolutely great. If you are more comfortable in C++ and you don't know Java, submit the bug report and submit a fix for C++, and we'll take care of porting it over to Java. Improvements, large and small, to existing stuff. So in 2016, we had some additions from community members for configuring SPI addresses and making SPI more generally usable. In 2017, we had a community member help rewrite the HAL effectively to improve simulation, and now he's part of the team and leading the charge on this VS Code stuff. And we did some PWM speed controller stuff. And in 2018, community members did timed robot. We did a robot drive overhaul and speed controller group. These are all things that are good changes that had C++ and Java and tests. And other things that are useful are reusable library components. Everyone, or a number of teams, it seems, are using Xbox controllers these days to control their robot. Before 2017, we didn't have anything to let you just automatically work with Xbox controllers. Now we have that. Adding more controllers, if they're actually used by more than one team, is often quite useful. And 2018, we're currently working on lo-fi simulation, namely being able to unit test, not necessarily on a real robot, but you tell the robot that it went 5 feet, and then what does your program do after that happens? And so that's the type of thing that we're looking for. If you're going to start implementing a large feature, please ask before just sending us a giant pull request with several thousand lines of changes. We might not necessarily like the idea. We might want to implement it in a different way. We might not think that it's an appropriate feature for WPILib. And so we want to make sure we're not wasting your time by going through and making this huge change and then we say no. We don't like to do that. And so it's best to talk about stuff with us beforehand. And we particularly like features, as Brad said, that allow us to raise the floor, that allow us to help teams with less resources get more done. Because we don't need to help the teams that can do all this stuff already and have all the resources to do it. We don't currently, because we don't have enough volume of feature requests to need it. If we were to get enough, I think that would start to be something we would look at.
How long are your sprints?
No. Yeah, we don't follow a specific software engineering process like that.
Yeah, I stand up when I watch television.
So things to not contribute. Game-specific code. The game changes every year. I think you all know that. Team-specific code. Again, WPI, I think I've said this quite a number of times, but WPILib needs to be useful to the potentially 3,000 different teams who are going to be using it. And we can't take changes that are designed for your specific robot.
However, if you do have a change that seems like it could be generic, but you don't have the time to make it generic, we can help with that.
Yes.
If you talk to us about it, open an issue, say, hey, I have this cool thing, this is what it looks like, this is what it does, but I only know Java, I can't make a C++ version, or I'm not quite sure how to make this generic. We're definitely willing to work with everyone on that.
Like, for example, 254 has Cheesy Drive,
Yeah.
which we integrated under the name, what did we name it? They have a driving algorithm that we integrated into WPILib Suite under a different, I want to say it was differential drive? No, curvature, that's what it was. So we integrated that because a number of teams started using it, and it became all right, well, this isn't just applicable to 254 anymore. More teams would like to use it. So we made it easier for other teams to use it. So adding new sensors is hard because we need to test them, which means we need to have them in hardware. And if you're in this room because you're working for a company and you want to get a sensor into the kit of parts, please contact first. And Kate Pilot is the kit of parts engineer, and she can help you with that. We are still looking. This slide is mostly unchanged. We are still looking at establishing a white page of sensors. One of our contributors, Dustin, who's also the Robot Pi maintainer, has been creating a wiki, first wiki. I don't remember where exactly that is, but I know he has a number of pages like this. And if you want to add support for a new sensor, consider making it available as a library, like a number of our kit of parts partners do. And that will be able to be used by teams, and they can go and find your sensor. Also, please don't contribute major restructuring of library classes or major rewrites. We do accept ideas. Again, we rewrote the HAL a couple of years ago to enable sim support. So we do accept ideas, but talk to us before you go ahead and do things. We need to make sure that teams, as was mentioned earlier, teams come in at week 1 and they would like to start building a robot. And they would not like to learn an entirely new software library. So we need to make sure that changes are incremental, they make sense and are well documented to teams, and that we have an upgrade story considered for that. Right, so this is our schedule. So right now we're at championship. We've about pared down, I think, the list of improvements that we have for next year. By mid-May, we're working full speed on updates until around September. At that point is when beta team selection begins. We get about 30 teams per language to try the new stuff. That beta period runs from late September to October. And then that's when we stop doing new things. December, beta testing ends. All new features are frozen. We only start doing bug fixes. Late December, we create the final builds. And then finally at kickoff, any secret changes that we have for game-specific things, like the game data stuff this year, are merged, and then we post the images and stuff.
One way you guys can really help us is if you're really interested, if you're really kind of gung-ho about seeing this stuff and playing with it, getting the new stuff, sign up as a beta team. We have a lot of people that sign up as beta teams that really never do much with it, and so we'd really like to see some new teams come in that are kind of enthusiastic and want to really shake down the new software and use it. And so,
Absolutely.
Like it says on there, we get about 30. It's kind of about 30 teams per language, so about 90 teams altogether. And we'd really like to see some new, kind of some fresh blood in there to replace some of the teams that don't contribute a lot.
And that will probably be announced in the
Yeah, they'll be announcing the FRC blog, and there'll be some form you fill out or something, and kind of say what you can do with it and why you want to be a beta team. And then Kevin then selects you.
Right. So with that, that's the end of our presentation. So any questions?
Yes.
Hold on. I'm gonna walk around with the mic so that it gets on the recording.
So a lot of times you talk about keeping parallel between the C++ and the Java. I know the hardware abstraction layer is just binded to both languages. Is that also done with the main WPILib stuff, or is that rewritten?
Yeah, the part that interfaces with the hardware, mostly, the hardware and some of the field stuff and, that kind of stuff is in the HAL. So it's only implemented once, and you get exactly the same results for both languages. And then the other stuff is built on top of that. So all of the, Java classes and all, that kind of stuff that you actually would tend to look at if you were trying to, if you want to try and figure out how the code works, is that. And then you get these J and I bindings from Java into the C++ code, and on the other side with C++ it calls it. So that's kind of how the split works. What other questions? Yes.
Well, not about this, but how going back to some of the other tools like the shuffleboard, is there going to be documentation for customizing that?
Wait 1 second. That was the signal that we should soon start winding down. I just wanted, this is our prearranged,
We're good.
our prearranged signal. So, but we'll. Okay, so a couple more minutes. So your question.
Okay, was customizing the shuffleboard.
Yeah, there's a wiki. If you look at the GitHub page for Shuffleboard, there's a wiki there, and it has a lot of examples and stuff about customizing Shuffleboard and adding widgets. And if you have more questions, just post issues on the Shuffleboard GitHub. Anything else?
Oh, one other thing is that we'll have Visual Studio Code, we'll have the Vision stuff up down in the WPI booth in the Robot Service Center. So if you want to stop by there sometime this afternoon, we'll to talk more or have see a little bit more live interaction, we'll be down there, and feel free to stop by.
Yes.
So in the presentation, I saw a fleeting reference to FRC sim. What is the plan for that, or is there one? Yeah,
so the original FRC sim that used Gazebo kind kind of wound down a little bit, well, for a bunch of reasons, but one of them was because the gazebos, the OSRF guys who do gazebo were supposed to provide a Windows version, and we kind of never got one. It's pretty awkward to have to flip into Linux to run the simulator, then come back to Windows to change your SolidWorks model, then go back to Linux and stuff. So what we're looking at, I mean, so that kind of stuff may reappear, a physics engine and nice simulation. The other thing that we're looking at, like Fred and Peter were talking about, was having stuff so you could write kind of some simulation layer stuff to do like unit testing or to verify your code or something like that beforehand. We're kind of thinking about it, trying to figure out exactly what to do, and there's some guys that are playing around with it. So I expect you'll see something for the fall. Anything else?
Testing follow-up, is any of the regression testing that you do as you pull and try to integrate available for us to try to use as we make a modification and break things and
Well,
before we submit?
our integration tests are running on very specific hardware, with things plugged in the right ports and all that kind of stuff. And that's this thing where I'm in a meeting in my office and all of a sudden motors start going.